So, well, first of all, a bit of an introduction. So my name is Jesus Barrasa, and I've been with Neo4j for the last 5 years or so. And one of the things that I've been working on is in this plugin called Neosemantics that makes it possible to integrate with RDF from Neo4j. And the kind of things that we're going to be seeing today that Neosemantics make possible is things like importing RDF data, exposing your graph in Neo4j as RDF, do things like model validations based on SHACL, for example, and some other things. But I guess the focus for today is to give a bit of an overview of some of the new features that we've included in 4.1, which was released last week. So before I get started, just a couple of pointers. So what you see on the screen is the Neo4j Labs page, where you see a number of projects. Very interesting, you might be familiar with some of them. So there you find a link to Neosemantics, so you can get from there access to the manual, some examples, help on installation, and so on and so forth. So that's probably your best point of access to all the materials that I'll be sharing today. So my plan is to have a totally hands-on session. So I've not prepared any slides. So what I'm going to be showing you is me writing code and writing Cypher, and showing some of these features in Neosemantics. I'm also be going to, I'm trying to monitor the chat in case there are any questions. Feel free to interact, and anything that's unclear or anything you want me to cover, please let me know. So starting point, like I said, is a completely empty database. So all I've done is just install the plugin. It's like any other plugins you might have seen before. So you just need to copy the jar file in the plugins directory, and off you go. So I'm going to start by probably the simplest example of import RDF, just to give some context for those of you who might be less familiar with it. And what the example that I'm going to use is a simple RDF file that I've created on and I've put on a GitHub repository. So I hope you can see it. But basically, it's a simple turtle file where I describe the Beatles band, right? So there's a description of. I understand that most of you probably are familiar with RDF. So you see that I'm describing a resource that I identify like the Beatles using a namespace IND, which I define here. And I'm stating things like, the Beatles is a music band, it's also an artist, and it has some properties like the name, and it's connected to the members, right? And for each one of the members, there's a small description. So pretty straightforward, there's nothing special about it. There's information also on one of the albums and one of the tracks, one of the songs in the album, but it's and then something similar to the Rolling Stones. But it's a pretty simple and straightforward fragment of RDF. So what I'm going to do is show the basics of how this import happens, right? So and in order to do that, I'm going to just grab a little fragment of this file, just the first bit here, where I describe the band and the connection to the members. And I'm going to go to my Neo4j browser and show you how can I use it. So Neosemantics is implemented as a set of store procedures and as an extension that we're going to be having a look at as well. But the procedures can be accessed from the browser, from your code, and you get access to them by typing. You can write NTNS, which is the acronym for Neosemantics. And you get the whole list of procedures. It's a long one. So what I'm going to do first is a preview. So one of the things that you can do is to RDF preview. So before I actually run the import and persist the results in the database, I can see what it's going to look like, and that's what preview do for me. And you will see that preview has two flavors, and that's common to all the procedures that you'll find. One is called fetch, and the other one is called inline. So the inline is created to take a fragment of RDF as a parameter, whereas the fetch will take a URL, a pointer to a location where we can retrieve the RDF, and that can be a static file like the one I've shown you. It can be a service, it can be a SPARQL endpoint that produces RDF, it can be anything. So for this example, I'm going to use the inline mode, right? So if I go with inline, all I have to do is pass the fragment of RDF and specify the serialization that I'm using. Because this is turtle, and to make it more readable, I'm going to introduce some line breaks there, and I'm literally pasting the fragment that I had taken from the file, right? So this should be a bunch of triples, 1, 2, 3, 4, 5, 6, 7 approximately, and I can see what they would look like when I import them in Neo4j. So if I go ahead and run this, I'm gonna get an error, and this error is telling me that before I carry out any import or even any preview, I have to create a config, and a config is basically an object in our graph which describes how this transformation from RDF into Neo4j graph, into property graph, is going to happen. I can go with the basics, with the defaults, so I can do something like init. This is the method that initializes it, and I can, like I say, go with all the defaults. And this is going to create this basic configuration for us. So I won't go into all the elements, but you can define things like, for example, how to deal with URIs. As you know, in RDF, all the elements are uniquely identified, resources, but also properties, relationships, types. So that's important, of course. But when I import into Neo4j, I may want to keep it in case I want to regenerate it, or I may want to just ignore it, right? That's one of the things that I can specify. By default, they're going to be kept, but they're going to be shortened. I'm going to use a kind of a prefix notation to make names more usable from Neo4j instead of having to handle the whole URLs. But there's many other things that you can configure. Things like, for example, how do I deal with multi-valued properties, right? Do I want to, again, ignore it and just keep one single value? Do I want to combine them all in an array in Neo4j? There are many options there. How do I want to deal with types? Types can be mapped to labels in Neo4j, but they can also be represented as a separate node. So there's a number of options. But for now, like I say, I'll go with the defaults, and now go back to the attempt to do this preview. Hopefully now I should be more lucky, and I get something that looks like a graph. It's exactly what I was expecting, right? So we see a node at the center representing the Beatles, and we see that it's connected to the 4 members, right? So there's been a kind of an automated translation from RDF into the property graph, and essentially what's happened is that data type properties, properties that has in RDF that have as object a literal, will be transformed into node attributes. So you see that here, this node, the Beatles, has a property called name, which is the Beatles, right? And it has a URI as well. URI is the unique identifier. But you can see that what's happened, and I'm going to close this bit here. If we go back to the RDF, when I say that the Beatles have a property called name with this value, this is stored in Neo4j as a property of the node. But on the other hand, the object properties in RDF, the ones that connect to other elements, and these other elements will be other resources like John Lennon, Paul McCartney, etc., are transformed into relationships in Neo4j. So we see that it's a connection of type member that connects to something for which I don't know much yet. I only have its URI. I know it's a node representing Ringo, but I still have not imported the attributes and the rest of the information because I just pick the header. So that's basically it. I mean, you notice that things are being prefixed with this NS0. So the reason for that, like I was saying, is that by default we're going to try to keep the namespaces, and we do that with this prefix, and which are going to be generated dynamically, NS0, 1, 2, 3, etc., unless we want to define them ourselves to make the graph more readable. So that's pretty much the mechanics of the input. At the moment, nothing has happened because this is a preview, like I was saying. But the moment I replace preview with import, this is going to be persisted in the graph. So good. So like I was saying, I don't like these NS0 and NS1, etc. So I want to define my own prefixes, and I want to use the ones that are being used in the RDF document. So there's a method that we have in Neosemantics that will do that for us. is NS prefixes. We can add them manually, we can list them. At the moment there should be none because we haven't created any, or we can import them from an RDF fragment, which is this add from text that basically will take a fragment of RDF in any serialization and we'll try to extract namespace definitions. So what I'm going to do is again take a fragment. In this case this is just a 2, but I could take any random fragment, and if I do that, it's detecting that there's 2 namespaces, and if I now rerun the input that I did before, it's going to look slightly better because now the prefixes are aligned with the ones in the document. That's just pure more user-friendly, but it's exactly the same. So the RDF is preserved. So enough about preview. So we can maybe just we'll go ahead and run the input of these data sets. So we're going to now do an RDF import, and this time we're going to fetch it directly from the URL. Instead of me copying a fragment and pasting it, I'm going to put the URL, and again I'm going to specify that it's a turtle format. So remember one thing, so if I take that URL, it's not going to work because this is actually HTML. We have to go to the raw format because that's what's going to actually return turtle serialization. So if I do this, interestingly, I'm going to get another error, but let's try. Oh, what's saying? It's telling us that it didn't work. I had a KO because there's a constraint. There's something that's required before we can actually persist some RDF in the graph, and that's basically a constraint. So we have to, and it's quite handy because I just need to copy these and paste it. But essentially, what we need to do before we persist any RDF is create a constraint in on the resource label. Any resource, RDF resource, is imported into Neo4j as a node, and it's labeled as resource, and it's given a URI, a unique URI, because we want to be able to uniquely identify. We want to be able to incrementally import RDF and things merge transparently without us having to do anything else, and that's all done based on the URI. So this will guarantee that we don't have duplication. We will never have 2 nodes with the same URI, which is the whole point of URIs. And it will also implicitly create an index which will accelerate some of our queries and operations on the graph. So if I rerun what I just did, this time hopefully we'll be more lucky. Okay, so 53 triples were imported. These are the namespaces that have been used, and there were no additional params because I used all the defaults. So if we now have a look at the graph, hopefully, let me refresh because sometimes it doesn't pick it up. There we go. So now we have a number of labels here. For example, I can see some albums. Let's change the style so we can make it more readable. So we have the 2 albums. One is the White Album from the Beatles, and Out of Our Heads from the Rolling Stones. But you see that we've created a graph just by importing the RDF, right? So and we have tracks, we have the artist, the members, and so on and so forth. So successful import. Good. So that's not new. That's been there from the very beginning. So it was just kind of some context. But what's new in 4.1 is that now we can use RDF-star. RDF-star, as you may know, is it's kind of an extension of RDF that makes it possible, among other things, to serialize things like properties of relationship. Is a way of doing a much nicer verification, so without having to do actual verification. So and that used to be one of the traditional limitations, right? So that you can set properties on relationships in the property graph, but then you didn't have an easy way of serializing them as RDF. So that's one of the things that we've included, and I want to show that to you now. So we've shown how to import RDF. Now I'm going to show it how we can present the content of the graph in Neo4j as RDF. And like I mentioned before, we have an HTTP extension that I can invoke from the browser using get, that generates an HTTP GET request on this browser. So I'm running it locally, so that's 7474. All this is in the manual, but basically I've mounted this extension in the RDF URL. Then I have to pass the name of the database because I'm using the default one is Neo4j. But if you're working on any other database, you know that we can have multiple ones from Neo4j.4. You have to use the name there. And one of the first things that I can do is do a describe. To do a describe, I have to pass the unique identifier of a node, right, or an element in the graph. So let's say I'm going to take the Beatles, for example. So what I need is to take its URI. So let me copy the address, and I need to paste it. The problem is I need to URL encode it to pass it. Let me do that. Actually, if I paste it, I'm going to get an error. If I do that now, let me reduce this. So, but I can URL encode it just by calling. Well, there's a number of ways you can do it, but we can use APOC, for example, text URL encode. It's just to pass the parameter. I mean, you can use any URL encoding utility on the web. But if I take this URL encoded version of the identifier of the node, hopefully that should produce an RDF serialization. And by default, is using Turtle, which is the default, of course. And it's interesting that you can probably see here that we're reproducing exactly the same RDF that we imported, and that's why preserving the namespaces is sometimes important. So you see that these prefixes that we're using here are being translated into the actual URIs in RDF, and of course you can do things like change the serialization format. You can do it in a couple of ways. So you can say I want it in RDF-XML, for example, and get it serialized as RDF-XML, or as quite popular these days, JSON LD. You can get it as JSON LD, well, you can do more things. This is just exposing an element based on its URI, typically a node. But you can also run a Cypher query and export the result as RDF. So that's probably one thing that I'm going to try now. So let's write a simple query here. So you can see what the graph looks like. So maybe I can say, okay, find me a band, for example. Oops. A music band. That is connected maybe to a member, right? So has member, that would be a member. This would be an individual. We can say that this typically would be an artist. And what else? So like this, we're navigating this sequence, and then the artist, maybe we can have them connected to tracks. So sometimes when they're the authors of one of the tracks, there is a connection called writer. So I can say, for example, writer, so is the writer of a song, right? So this would be a song. Okay, so that would be a pattern, for example, and I may want to do it, for example, where the band is the Beatles. And I can return. Well, one way, easy way of returning is putting these all in a path and return the whole path. Okay? So if I do that, and I have made no mistake, B contains. Of course, B doesn't contain B.name, right? That's. I think that's the name of the band. That's the property that. There you go, music name. Perfect. So if I rerun it, now I get two paths actually, starting at the Beatles, and one is for Paul McCartney and the other one is for John Lennon. And they both connected to one track, which is Helter Skelter. Well, that's one possible example of query. So what if I want to serialize this as RDF? So I can, I can take this cipher fragment and copy it. And I'm going to do exactly the same. This time I'm going to do a post request. Actually, I have here this REST client, which is going to make my life a lot easier. So Right, let's start a new one. Oops, so I had a previous one. What I want to do is call, instead of describe, I'm going to be calling a cipher endpoint, right? And in the cipher endpoint, let me remove this for now. I need to pass the authentication, of course. I can skip the authentication from the browser because it's already authenticated, but when you run it from a client, of course, you have to pass your credentials. And the body is going to be a JSON structure. So we can add, for example, the query, which is what I've just written, paste it, and well, that should on its own produce some results, hopefully. Here we go. So we're getting the result of that query, basically what we saw visually here, but now serializes RDF. So we get the Helter Skelter song with the length, the name, etc., and the link to the Beatles and John and Paul. So all good so far. Pretty much like we did before, you can change the format and say, well, I've done turtle by default. Let's say JSON LD, and just the same query should produce a different serialization, this time in JSON LD. So that's the kind of the flow, the input and the input and output. Now, I was mentioning before that one of the things that we can do now is use RDF-star. So how can we simulate that? Well, this dataset doesn't, because it's the result of importing RDF. It doesn't have any attributes in relationships, but we can do that pretty easily. So we can say, for example, I don't know, let's say when we have a song and a writer, we can have some sort of role or the level of involvement of the musician in that. So I can do something like, and we can encode that in the writer relationship, saying that this is the writer, but he wrote the lyrics, or he wrote the music, for example, something like that. So I'm going to do an expression that finds a song, and the song will be connected to the authors through the writer relationships. So this will be the author, and I'm going to specifically say that for this is Helter Skelter, I'm going to say hs.name contain Helter Skelter, and also, and the author dot name is, for example, or contains as well. I can use equals, but it's sometimes you need to match the. Let's say for example for John Lennon, we can get the name from here. So I can say what the name of the author is exactly John Lennon. Let's see if I'm matching it right. So good, so I'm getting them. The reason why I was doing this is because I want to add an additional property in a relationship. So this is the writer, this alias with a W relationship, and I'm going to say, okay, I want to set a property saying that the involvement of John Lennon in Helter Skelter was, for example, and we can name this relationship, let's use the same namespace so that it's consistent. Let's say role. I don't know if calling it role, but you can name it the way you want, or according to your schema, to your ontology. I'm going to say that John Lennon's role in that song was he was the author of the lyrics. I'm making this up, so if you're a Beatles fan and I'm saying something that doesn't make sense, don't angry with me. Right, so if I've written my cipher correctly, now this should be setting a property. So the model hasn't changed significantly. I can refresh this query, and now we'll see that hopefully in the relationship that connects John Lennon to Helter Skelter, we see now that there's an additional property, one property called music role, and it says that he's the author of the lyrics, right? Good, so let's go back to our query. So if we run this, let me remember, yeah, that's our query that indicates, let's use turtle, which is, actually we can use n triples, which is also pretty readable. So if I run this, no, not bunch, it has to be a bit smaller. Let's go back to turtle. Right, so if I use turtle, we see, well, helter-skelter, and one of the things that we're saying is, hang on, there is a relationship between helter-skelter and John Lennon, but we're losing this information, right? The fact that his involvement in the writing of the song was writer of the lyrics, and that's because, you know, the traditional serializations of RDF do not have this possibility. You have to find workarounds, like I mentioned before, like serialization and others. But now, one of the good things that we can do is say, okay, I want to serialize it as RDF, sorry, as turtle-star, which is one of the serializations by RDF, available for RDF-star. And if I just rerun this, hopefully we should see something slightly different. And you see that there's an additional triple here at the bottom. So all the rest is exactly the same, but we have an additional statement, which is a statement about a statement. So it says that effectively John Lennon is linked to helter-skelter through the writer relationship, but in addition to that, we have an extra statement, which is that his role was author of the lyrics. Well, that might be a small thing, but I think it's pretty significant. It's important because it's a great and simple and intuitive way of serializing things like relation properties in relationship. Let me have a quick check, see if there's any questions so far. Good, no questions. So, well, that's the first one of the ways in which you can leverage this new feature. Of course, you can import it as well. So let's say, and actually we can probably eat our own dog food in a way. So I'm going to use this example to show you how we can import RDF-star and turtle-star in particular. So one thing I can do here is I'm going to empty my database, everything, and hopefully, yeah, that should be empty now. We still have the index in resource, which is good. So what I'm going to do now is I'm going to, well, let's initialize, otherwise we're going to have the same error. So we have to call the config init. So I'm going to use the basics. And I'm going to try to import this RDF-star. So all I have to do, as I did before, we're going to import via inline. I'm going to pass the RDF itself, and I'm going to say that the format, the input format, is turtle-star. So I'm going to take here the RDF that we had generated, and I'm still holding here, and I'm going to copy it. So let's copy that and paste it here, which was one of the modes of operation. We can do these inline or a fetch. So if I run this, it's successfully imported 15 triples, right? And because I removed the namespace definitions, now it's using NS0, which is the default mode of operation. But what's interesting, and what I want to show you, is that we have, let's again reset style. We have a song, helter-skelter, connected to John and Paul, who are also connected to the Beatles as a node. But let's have a look at this writer relationship, and we see that, as you can see, we have successfully imported this attribute of the relationship. So simple example, it was a rather small one, but it kind of proves the two-way trip, right? So you can expose properties or attributes, if you want, in your relationships as RDF-star, and you can also import them, right? So there's another, I mean, here we started with this approach of, yeah, have some RDF, I'm going to import it. But sometimes, and this is one of the questions that I keep getting sometimes is, you know, I have a property graph, I have not imported it from any RDF source. Can I still, you know, export it as RDF and leverage these kind of capabilities? And the answer is, of course, yes. Let's do this again. So let's empty the graph. Empty my graph, and let's take the most popular sample datasets, which is the movie database. If you do play movies, that will bring up this guide, and you can quickly import it. And it's a pretty simple data set. So we can, for example, get people representing either actors, directors, producers, and movies. And there's connections between them. So we have, for actors, we have the acted in relationship. So for example, Hugo Weaving acted in The Matrix. And this data set does, and of course the Matrix will have all the other actors, directors, etc., etc. So this dataset already comes with a number of properties in relationships, and in particular we use that to model the role that an actor played in a movie. So for example, Hugo Weaving in The Matrix was Agent Smith, as you can see down here, right? And that's similar to others. So yeah, that's a great candidate to. This is not the result of importing RDF, but still, you know, RDF is a model for data exchange. So I can still serialize my graph in a kind of automated way, applying the same sort of transformation by invoking exactly the same mode as I showed before. So I can do a get request, and I can also show that on the REST client. But here I'm going to do HTTP localhost again. Localhost 7474. RDF is the endpoint. My database is Neo4j, and I can use, like I did before, describe, which is the simplest one. Now the problem is I don't have URIs because these items, you know, just are not the result of importing RDF, but they have a unique identifier which is local to Neo4j, and that's its internal ID. I know it's not ideal, you know, we shouldn't be using the internal ID as, but it's one possible way. I mean, we see that can be used in another way, but for now we're going to use the internal ID, and the internal ID of nodes for Hugo Weaving, you see it's 27, so that's a numeric identifier that's unique for every node or relationship in the database. So if I do that, that's going to return a serialization of that actor. So what's happened? I don't have a formal definition of the schema, right? I did not define a proper namespace. I didn't create an ontology, in other words, for my schema. So I know my, I think we can get it. Is that schema for visualization. So we can see our schema. We can say, well, our schema is pretty simple. It's form. Let's change again. My browser is a bit silly with the presentations. But yeah, we see that schema is pretty simple. We have two types of nodes, two categories, two classes would be the equivalent in RDF. Which is movie and person, and there's a number of types of relationships between them. But this has never been formalized in an ontology, so I don't have a specific namespace. So when I serialize, and that's what's happened just here, I have to take one by default, and that's the one that Neosemantics uses. So it creates a basic one for schema elements and another one for URIs, for identifiers for individuals, right? So we get that this is the unique identifier of Hugo Weaving, and we have the rest of the elements serialized as properties or relationships. So again, if I use the default, which is turtle, I'm not getting things like the properties in relationships. So when he acted in movies here, I know that, you know, there's a connection, but I'm losing the information about the role he played. But again, like we did before, I can say let's use the format turtle star, and hopefully that should produce, just like happened before, a bunch of additional triples where we have, okay, for each involvement in a movie. So we know that Hugo acted in this movie called 32. I don't know which one is this, but I could write a cipher query to return it. Well, we know that not only that he played a role in that movie, but we know which role that is. So in 32 in particular down here, he played Agent Smith, sorry. So that's obviously The Matrix, or maybe one of the different releases, maybe one of the, but yeah, that's how we can serialize RDF-star out of Neo4j in a pretty straightforward manner. Good. So I hope that was useful. I don't see any questions, but if there's any, feel free to write there. So that's I would say the main feature that we've included in 4.1. I think that's it's an interesting one. So one possible, I was looking at conversations in the RDF-star distribution and list, and people were asking for data sets. So here you have an easy way of generating data sets from Neo4j. I mean, you load data that you may have, and you can just export it as RDF. You can serialize the whole graph. Of course, you can write a simple Cypher query that returns everything, and you can use that pretty much the way I explained before. Good. What else can we do? So that's about RDF-star. So one of the things that was included in 4 is support for SHACL, right? SHACL is a vocabulary. It's a way of defining constraints, shapes, as they call it in your graph, which is a convenient way of defining how you expect your graph to be, and what you expect it to be structurally like, and be able to run automated validations and detect violations of these constraints. So that's one thing that we found really interesting and was included in 4. And we've added some extra coverage because it was not full in the initial version. So I'm going to show another example, well, one example based again on the Beatles dataset, on how we can use it in Neo4j. So yeah, let's refresh that so we get a clear browser. I'm going to also empty my database. Of course, I have to use the same variable. So we have an empty database now. And right, so let's see what that looks like. So in my repository, the one where I show you the dataset about Beatles, if you go, I'll share all these links at the end of the session with you all. But in the folder, there is a, in the RDF folder, there's what's called music shapes. So you have a SHACL. Again, SHACL is serialized as RDF. So this is a definition of some constraints on that model. So it's essentially different from an ontology. For those of you, well, for those of you who are not familiar, because those of you who are familiar, you probably know this. But it has a completely different semantics, if you want. An ontology does not constrain your model. It's not built to enforce a structure as traditional constraints in relational databases do, but it's more like an inference-based definition. So what the information in your ontology will make it possible for you to derive additional information, or even detect inconsistencies, semantic inconsistencies on your data. What shapes do is exactly the traditional thing. It's like when you create a band, and let me read this first example. When you create an instance of a band, right? That's what I'm saying by target class band. So when we create an instance, an individual of type band, you have to make sure that you comply with these constraints. And the one we're defining here is a constraint of type cardinality, right? So it's telling you that property name, right, which is one of the properties that a band can have, will have a minimum cardinality of 1 and a maximum cardinality of 1. In other words, what we're saying is that a band can have only one name. I don't know if there are exceptions to that rule, maybe there are, but that would be an invalid case in our database. So that's the type of constraints, and there's many more. So for example, you can apply also to relationships, not just to properties. So you can say that a band can only have a certain number of members. That's a silly one, but it's an example, right? So it's telling us basically that the member relationship, there's two constraints here, will connect to an individual of type artist, right? So it has to be of that type, as opposed to the ontology meaning, where you would say, well, if a band is connected through something to something through the member relationship, then you can derive that it's an artist. In this case, we're saying the element at the other end of the member relationship has to be an artist. If not, that would be considered a violation of this constraint. And again, I'm setting some cardinality constraints saying that the number of members in the band have to be between 2 and 4, which just, as you can imagine, to generate some errors and be able to pick them up in the example now. There's more, right? So you can define things like constraints on data types. You can define constraints even on regular expression-based constraints to define the shape of a string value or a numeric value. So I won't go into the details of what can be done, but this is just one example. And like I did before, I'm going to use the raw format to import it in Neo4j. So one thing I can do is is import these shapes. So there's like we saw before, there's an input, and as usual, there's the fetch and the inline. So I could I'm going to use the fetch in this case. It's again serialized as turtle, and the URL is the one that I just cut, right? So I should get an error, of course, and as usual, oh, what's the unrecognized, yeah, wrong serialization, turtle. But the error that I was expecting, no, it's not. That's good. Do I have a, oh, I already had a config. Good. Let me actually do again add detach, delete, and rerun it to make it more clear. Actually, maybe what I should do first. Right. So let's create the config initially, because well, not that it's critical, because it's actually not. As you can see, we can import it before defining it, but I'm going to go with the same approach as before, but with slight different. And let me show you what I mean. So one of the things that I can do is ignore the URIs, and I'm going to use this example to show you how to do that. So I can I can override the defaults when I create a configuration, and for example say that I don't want the namespaces, the URIs, to be shortened like happened before, but I want to go with the ignore option, which essentially means that I don't want the prefixes, I don't want the URIs, just keep the local name and ditch the rest. So yeah, if I set that, we see that this has been updated to ignore, and now I can both import my constraints and my data. Let's run that again. When I import the constraints, right, so we have, as you can see, a listing of all the constraints in the document that I just showed you before, this one here. And well, it's more kind of a more human readable version of it. So we say that there's a constraint on the album where the date has to be of type date, right? So we can specify the data type of a particular property. Also the cardinality, the min and the max have to be 1 and only 1. The track from album has to connect to a class of type song. Well, you see that's the kind of a tabular listing of the constraints that we have created. Now I'm going to import the data, and I'm going to do exactly the same way as I did before. RDF import, fetch, and I'm going to use the same URL and the turtle serialization. Let me get back to my Beatles and Rolling Stones file, which is this one here. Again, I need to get the raw format of it and pass it here. Hopefully, yeah, that imports the 53 triples, and you will see that when we look at the graph that it looks slightly different than before. So now we have a band, but it's there's no prefix like we saw before, and yeah, we've lost that piece of information, which is fine in some cases, maybe not so much in others, but just for this example to show that both are possible, I went with that one, right? So good. So I have data, and I have a set of constraints that have been imported, and in the process of importing, they're kind of compiled in a way that can be run against my graph. And the way to run this validation is by calling SHACL validate method, that one at the top, And what this method will do is we'll take all the rules and apply them to the existing dataset and produce a summary, a listing, more than a summary, a listing of all the violations. And we see that there's one that applies to this particular node, and it's a band, and it's breaking on the maximum count constraint component. That's the SHACL kind of precise term, but essentially what's happening is that the property of the relationship, in this case member, is connected to too many individuals. So it's a cardinality that's not accepted according to our constraints. So if I release them, if I click list my shapes, we saw that a band could have, and this is these two here. Oops, I didn't mean to do that. So there's a minimum count of 2 and a maximum of 4, as you can remember. And of course we have the Rolling Stones, who are 5, so that produces a violation. Now that's kind of a batch, if you want, an after the fact validation that you run on your graph, which is fine. It's useful. Actually, let's show how this is completely dynamic. So this validation is run on the fly. So I could either create additional constraints, or I can fix the problem, and I can say, well, let's cut. I don't know. I don't want to be mean, but let's take, for example, Bill Wyman. So let's take him and let's remove it from the graph, right? So we can say that there's an individual, which is an artist. Actually, we can do it like that, where a.name contains what's. Let's see if I'm doing it right. Good. So I'm going to just, rather than returning, I'm going to remove it. I could disconnect it from the stones. Actually, would be also possible. Actually, let's do that rather than deleting it. So we'll see that the artist will be connected to something. Relationship, and actually let's use the PO predicate object, since we're talking about RDF. And we can say delete P, delete all the relationships that we may find. Basically, that's going to leave, if I made this right, there was only one. So we should still have the node representing Charlie Watts. So it's still there, but now it's an orphan node, so it's not connected to anything else, which is probably good, because that was the constraint that was failing. So if I rerun it, I have a clear list of validation violations. So there you go. So that's I think I'm gonna stop it here, because it's most of the time that I had assigned. Let me see if I have any questions. Good. Nothing specific about this. So yeah, I will probably not going to show it now, because it takes a couple of minutes to set up, and I'm not sure going to have time, but I can do. And I've shown how to run the validation. Well, let me show some functions. You can validate a specific set, so you can select a bunch of nodes and just apply the validation to those nodes, right? So you can have it as part of this would take a list of nodes here. So you can have in your cipher, you can have a previous match expression where you decide how to select some of these nodes. You pass them into a variable, and then you can then apply your validation to just a subset of your graph. That would be a way of working in larger data sets. That said, it's pretty performant, so I suggest you give it a try with large data sets, because the engine, the validation engine, tries to be clever and identify the bits of the graph that are affected by the validations, by the constraints in SHACL. And yeah, so I think performance is quite decent. The other thing that I wanted to mention is that not only you can define the subset of elements to which you want to apply the validation, you can also have it run and applied transactionally. And let me show you what I mean by that, because I'll go to the documentation of 4.0, And if you go to the validations in SHACL, this pretty much goes over what I just said. So it shows you an example, how to import the RDF, how to import the constraints, and then how to run the validation. So that's exactly what I just did, right? So and this is the result in this particular example, how you can constrain it, just what I was saying. This works on the movie database, so you can take it as an example and run it. But the interesting one is validating transactions. So what I want to do, and what I want these transactions, these validations to be applied, is not after the data has been persisted in the graph, but as it's written to the graph. So I want my transaction, my write transaction, to be validated on the fly, and only if no constraints are violated, then I commit my transaction and I persist the data in the graph. If there's a violation, the transaction is rejected, is rolled back, and no changes are applied to the graph, guaranteeing consistency. So in order to do that, you have to combine Neosemantics with APOC. APOC has a capability which helps you defining triggers, right? So all you have to do is literally copy that line here, as is. So this method exists already in Neosemantics, and what will happen is that when you write to the graph, and that will be a normal write operation, it doesn't need to go through Neosemantics, it can be a simple creation of a relationship. For example, in this case here, I'm saying that Emil is acting in a play, but I had said before in my constraints that acted in has to connect to a movie, because it's my movie database. So that throws an error, a transaction error, and then you can get the details pretty much like we saw before, but in the as a detail of why the transaction was failed. So I'm not going to do that now because we're running out of time, but that's definitely one very interesting way of using it in a more transactional fashion. Good. So there seems to be a couple of questions. Let's go through them. So you can import OWL with Neosemantics and have Java drivers to work with Neo4j, or you could call the Neosemantics functions. Yeah, absolutely. Yeah, one of the reasons, well, one thing now that I'm, one method that was included, do we have, is, let me write it here, is SPO. So that's an export. Let me see. I can't remember if that was the way. Yeah, that's so basically that's the traditional way, the triple pattern base to access the data. So it's a way of serializing as triples, but using this subject predicate object SPO way of constraining my my results. So I can say, give me all the results where the subject is the Beatles. Right, so I can set the subject and I will get a subset of these triples, but only the ones where the subject is the Beatles, or where the object is the Beatles. Right, so we can, and the reason why this was included is because this is enabling, so there's only one where the White Album is I was saying that this is useful because this will enable interoperability with other drivers. So I've done a lot of work with RDF4J, and probably if you write Java code using RDF4J, you will want to not necessarily know that Neo4j is behind. You want to interact in this kind of mode, and that's something we're working on at the moment. And the same for RDF-lib. I don't know if I can show a simple example here, but I hope that's readable. So if you're familiar with RDF-lib, which is a Python library to work, I think it's the most popular out there to work with RDF. So you can write RDF-lib native code, but defining your graph as backed by Neo4j. So we've created a store, RDF-lib store based on Neo4j, and you can, if you look at the code, you can write to the graph as you would in a normal way with RDF-lib, but behind the scenes, this is sending write requests through Neosemantics into Neo4j. So probably that's just a very quick mention of it. I'll talk more about it in future sessions, but that's one of the reasons why we included this SPO way of interoperating with the graph. More questions. Would it be possible to import OWL in Neo4j? embedded in Java applications. Yes, I mean, because from a Java applications, and I invite you to go to this repository. I mean, it's more Python, not Java, but yeah, from Java you can interact with Neo4j using the Java driver that you can get from our downloads page, and you can communicate pretty much in the same way we did today. So you can write cipher fragments and pass the OWL if you want from your Java applications. And same with Python. I was going to refer you to a repository that I created with some Python examples. The problem is they're based on 3.5, but if you Python examples, here we are. So if you go to Jesus Barrasa, which is my user, and you will find a repository called Neosemantics Python examples. So they're based on 3.5, so there might be small changes in the syntax. But you have a bunch of examples there that shows how the kind of things that you can do from Python code interacting with the Neo4j driver. That's again interacting with Neo4j with the Neo4j Python driver. The approach that I mentioned before, based on RDF-lib, is completely transparent. So you would be writing RDF-lib code, and behind the scenes it will be persisted into Neo4j. Good. Another question. Database. Oh yeah, I didn't mention there is a graph app today. All the session was based on me writing code in the browser, but we have a very cool app. Let me bring it quickly here. So I'm running my Neo4j instance from the browser. So one of the things you can do is start the Neosemantics app. So these will help you doing a lot of things that we've done today. So for example, it will help you defining namespaces, right? You can do it from a nicer UI. You can define mappings, which we didn't touch today. You can import your validations. You can do previews like we did. We can do import, and it will generate for every request. It will generate the cipher in case you want to copy it and reuse it. So it's a very didactic application. It's oriented to people who are starting with Neosemantics, and yes, I totally recommend that. Thanks for mentioning it. Does Neo4j implement an OWL reasoner? No, it does not. I intentionally stayed away from implementing a full general purpose inferencing engine. There are some basic elements for inferencing, and it's based on subclass of type of relationship, so kind of transitive closure type of inferencing. So I would recommend you go to the manual again, and it's very limited, but might be worth having a look. So you can figure out how you can derive types based on subclass of hierarchies and things like that. But it's pretty limited, and that's something I want to listen from the community on what would be useful, because I want to I think we want to be prudent on that. I mean, there's I think there's a lot of value in what we have, and there's general purpose reasoning engines out there. There's one by a partner company called Derivo that can connect to Neo4j and run, I don't know if it's full OWL or RDFS or some variants of it, where you can leverage that. But at the moment, no, Neosemantics does not implement a full OWL reasoner. Where to find the libraries for developers? What I'll do is probably I can reach out to the attendees, or maybe this video will end up, I guess, either in Twitch or in YouTube. So what I'll do is I'll paste all the links to all the elements, to the libraries, the examples, the manuals, and all the relevant information. So I'll do that. What else? What language do you use? Oh yeah, that's a question for yeah, I think we've covered. I don't know if I missed any question, but if I have, of course, I would strongly recommend you come to the community site, because we have a section, a very active section on where is it? Is it integrations down here? There you go. Link data, RDF, ontology, etc., etc. So there's lots of interesting questions that I'm sure will help you. But if you have any that we haven't covered today, I'd love for you to share with us here in the community side, and we'll answer it there. So I think we're done for today. Thank you very much for the interesting questions. Hope it was useful, and see you in the next one sometime soon. Thank you very much.